folks. Welcome to
Vector Calculus.
What's up, folks? Welcome back to the next lecture in Vector Calculus. Today is an extremely exciting day because I'm going to show you how to find the volume of a parallel pipette. What was that again? A parallel pipette. I'll show you what that looks like. It looks amazing. Hold on. Alright, so let me go ahead and show you what that looks like. This right here is an example of a parallel pipette. You might recognize it because it's a type of rectangular prism. But imagine you took a rectangular prism and you kind of kicked it, you shifted it. Alright, what would it become? It would look like a parallelogram, something like this. Imagine you took that parallelogram, you extruded it, okay? Then it would become a parallel pipette. Alright? And that right there, ladies and gentlemen, is a beautiful parallel pipette. Now, I want to show you today how to find the volume of this thing. You know how to find the volume of a rectangular prism. You've done it since pre-K. I'm going to show you how to find the volume of a parallel pipette. But first, I want to show you a kind of 3D demonstration. This is as 3D as it gets, folks, in my lab at least. So, this is the length, this is the width, this is the height, okay? The length, width, and height of my parallel pipette. And unfortunately, I'm not very adept at these things, but I think we can get it working. Now, here is a rectangular prism, right? All three of my kind of vectors that determine my length, width, and height are perpendicular to each other, right? You can imagine that. Look at this, right? Can you imagine it? All three of my sides are perpendicular to each other. My length, width, height, all perpendicular. Now, imagine I took my height and I kind of slanted it. Did you see that? That was subtle. Let's try that again. This is a rectangular prism. All three sides perpendicular to each other. Now, take the height. Take any of the three, length, width, or height, and slant it, right? Now you see it's not perpendicular anymore. It's kind of slanted. How do you find the volume of the prism defined by these three vectors? That's what we're going to check out today. All right. So, first things first I want you to do is think. How do you find the volume of a rectangular prism? Let's start with what we do know. Well, remember, every rectangular prism has three things, right? Length, width, and height. And this is the length, here's the width, and here's the height. And so the volume of any given rectangular prism is simply the product of these three quantities. The length times the width times the height, boom, you're done, that's it. That's the volume of a rectangular prism. How do you find the volume, however, of a parallel pipette, of this guy? How do you find its volume? Well, interestingly enough, it is not, what you might think, it's not length, width, and height anymore. It's a bit different, it's a bit harder. We do need the same things, right? Here, for example, you notice that you multiply length and width so that you can get the area of the base and then multiply it by the height. In other words, that common pre-K formula you remember is just the same thing as the area of the base times the height. Same thing here. We want to find the area of this base. The volume of this thing is going to be the area of the base times the height. That's where the problem comes in, right? The area of the base is easy enough. If you've got two vectors, call them V and W. The area of the base is just going to be the magnitude of their cross product. Can you see that? Imagine this is the base of my parallel pipette. Well, what's the magnitude of this base going to be? Well, this base, any plane, is determined by two vectors, right? So there's two vectors that determine this base. And so if I take the cross product of these two vectors, I'm gonna get the cross product. Take the magnitude of that cross product, it's gonna give me the area of my base. Alright, so the area of this base over here, area of base is simply going to be the cross product of V cross W, alright? Or rather, it's going to be the magnitude of that cross product. So why don't I put those kind of annoying bars over them? Okay, so that's the area of the base. How about the height? How do you find that height, that mystical, magical height? Well, to find the height, we're going to take the cross product. Remember, the cross product is going to be perpendicular to the base of our parallelogram. We're going to take our height and project this kind of oblique oblique side onto our height. Alright? So this oblique side, I don't know what you want to call it. You want to maybe call it K. We call this W, we call this V. Let's call this one K. We want to find the projection of K on to our cross product, okay? So here's our goal. Our height is going to be the projection of this vector K onto our cross product, VW, V cross W. All right. Okay, that's good. Now, how do we find this cross product? How do we find this projection? Well, hopefully you remember the projection formula, right? It's going to be the dot product of the vector we're projecting onto and the vector that's being projected divided by the magnitude of the vector that's being projected onto squared. Alright, so that's going to be V cross W. So that's it. That's pretty much all there is to this projection. And now we have our height, we've got the area of our base. Let's just multiply them. So we know the volume is going to be the area of the base times the height. What's the area of the base? It's this projection, right? It's the projection of our oblique height onto our cross product. Our oblique height onto our cross product. Multiply the area of that height. Sorry, I should have done my height first. Doesn't really matter. Anyway, so this is my height. And what's the area of my base? Well, it's simply the magnitude of the cross product. The cross product of what and what? Cross product of my two vectors that determine my base, the base of my parallel pipette. So let me go over this real quick. So we got our height, we got our base. Multiply them, find the product. So the volume of our parallel pipette will be V cross W dot K over the magnitude of V cross W. This simply is the projection, right? That's the projection. And here's the area of the base, right? Your height, your base. Multiply them, you get the volume of the parallel pipette, which is V cross W dot K. What is V and W? V and W are simply the two vectors that define your base of your parallel pipette. K is simply the oblique side of your parallel pipette. Okay. How can you remember this, by the way? How do you remember this without deriving all of this? Well, what you can do is just remember base times height. Right? This is your oblique height, and this is the area of your base. Right? So you can kind of think of it like that. The area of your base times your oblique height. That's it. Alright folks, check you out in the next lecture.
Ambition plus MKO plus scaffolding equal learning. We believe anyone can learn anything. That's why our motto is memorization is a crime. And that's why we partnered with Brilliant.
Brilliant transforms math and science into hands-on activities so that you too can understand everything from first grade math to E equals MC squared. Barry Science Lab and Brilliant is your MKO and will give you the scaffolding to expand your ZPD until you become the next Sir Isaac Newton or Albert Einstein.
Visit brilliant.org/Barry Science Lab today. And the first 50 of you to use that link will get a 20% discount on the Brilliant annual subscription.
Don't forget that you too can become the next Einstein. So let's fall in love with math and science.